Hello, welcome to another lecture of digital electronics. So today I'm going to discuss the SIPO register. Okay, so already we have discussed the basic concept of register in the last lecture. So you know that basically the register is a combination of D flip-flops or data storage flip-flops, where all the flip-flops are driven by a same clock. So they work in synchronous fashion. Okay, so here the basic concept is that so in the SIPO register, the, the the only difference is that your the output of one flip flop is connected to the input of the subsequent flip flop. Okay, so these connections are there in SIPO register. So what will happen is that, so if I give any, so in every clock pulse, what will happen that suppose this data is 1, this data is 0, this data is 1 and this data is 0. Suppose in every clock pulse this data from the this data will be shifted in the right or left side depending of the shifting operation. Okay, so in every clock pulse the data from the first flip flop will be shifted to the next flip flop. Okay, so if I consider the shift right shift, then what will happen, this in the next clock pulse this 1 will go to here, this 0 will go to here, and this 1 will go to here, and this 0 will be trimmed out, okay, from the system, and whatever serial input will be there, and that will become into the first at the output of the first flip flop. So this way the SIPO register works. So simply in every clock pulse the data will be shifted across the flip flops. So that's why it is called SIPO register. So that is the basic difference between a normal register and SIPO register. Okay, so simply this can be also schematically we can show this in short form, that 4 blocks are, these are 4 flip flops which are connected. So 4 flip flops are connected. So this is Q3 is the MSB and Q0 is the LSB, and simply D3 is the parallel is the MSB input, and parallel D0 is the LSB of the parallel data input. Simply we can have also a parallel data input, okay, and also we can have a parallel data output. So this is the simple form of SIPO register, and all these flip flops are driven by a single clock in synchronous fashion. Okay, so next is that, so what we can see that, so there are four possibility, right? Your data input could be serial or parallel, or your data output could be serial or parallel. Okay, so we can have, depending upon this scenario, we can have basically 4 combinations, right? So for data processing through SIPO register we can have 4 combinations, right? So I can have either serial input, serial output, or serial input, serial output, parallel output, or parallel input, serial output, parallel input, parallel output. So we can have 4 combination. So data processing means, what I mean is that data processing means you need how many clock you need to store the data. You have to store the data first, and then you have to read out that data and process the data. So you have to store and use it. So we'll see that for depending upon the particular scheme. So we can have 4 scheme using the SIPO register, right? Serial input, serial output, or serial input, parallel output, or parallel input, serial output, or parallel input, serial output. So we can have 4 scheme. Out of this 4 scheme, so depending on the scheme, the data processing will be different in the sense that how many clock cycles will require. So if I have a 4-bit register, so how many clock cycles is required to process the data? So process the data means first store it, and then read out it and use it. Okay, so let's see the case 1, that means the serial input and serial output. So here the case is that, so you have is a 4-bit SIP register, so I have 4 flip-flops, Q3, Q2, Q1 and Q0 is their corresponding output, and my data will be stored. My serial input data is, so my target serial input data is 0101. Okay, so this data will be stored in the flip-flop, and that will be serially we will take the serial output from Q0 and then I will use that. So let's see how that can be done. Okay, so it is pretty simple. So first of all, let's assume that initially my flip-flops, my register in recess state, so it is in 000 state. Okay, it is in 000 state. Okay, but it can be in any state, but let's take initially it is in recess state. Okay, so in the first clock pulse, what will happen? This first one will be shifted to Q3. Okay, and what will happen to Q2? So Q2 will become 0, so this will become 0 and this will become 0 and this 0 will be out, right? Because it is a shifting operation. So in every clock pulse, all the flip-flops are driven by the same clock, so it is if I consider right shift operation, so so this data will be shifted by 1 bit position. So in the next second clock pulse, what will happen? The data of Q3 will be transferred to Q2. Okay, so that will become 1, this will become 0, this will become 0 and this will become 0, and the second 0 of my data, my second data bit will be transferred to Q3. So in the second clock pulse I have 0 1 0 0. In the third clock pulse simply I will have 1 0 1 0, and in the fourth clock pulse we can see that my whole data, whatever data I want to store in my SIP register, that has been transferred to my SIP register. That is, after fourth clock pulse, the bit pattern is 0 1 0 1. Okay, and that is what I want to transfer, right? So after this, also after fourth clock pulse, I can basically read out my data, because whatever I want to process is that I have to store that, and then I have to start processing that. So once it is stored in my register, then I can start read out the data, but here I can only read out, I'm going to read out it serially. So in the fourth clock pulse itself, the Q0 is 1, so first bit position will be stored, so I can read out this data. So 1 will be read out. Okay, so in the fifth clock pulse, what will happen? This 1 will be out and then it will be shifted, and then I will read out 0. Then next 6th clock pulse I will read out 1. In the 7th clock pulse I will read out 0. So what we can see from this thing is that for storing the data I basically need 4 clock pulse, 4 clock cycle, or 4 clock cycle, and for using and for processing or for readout I need another 3 clock cycle, right? So in the 4th clock cycles I can read the first data bit, but I need another 3 clock cycle to read out whole data, whole 4-bit data. Okay, so for processing then I need 4 plus 3, total 7 clock cycle, right? So in general, if I consider a n-bit SIP register, then I need n clock cycle for storing the data, and I need another n-1 clock cycle for read out the data, and for total processing I need n plus n-1, that means 2n-1 SIP clock cycles. Okay, so that is the case, that is the scenario for serial input serial output SIP register. Okay, so let's proceed to the next thing, that is the second case, that is serial input parallel output shift register. So here also the data will be stored, suppose same data 0101 will be stored in my register serially. So simply again, if I consider that initially it is in recess state, then I need 4 clock cycles. So I need basically 4 clock, just like the previous case. I need the 4 clock cycles to store the data 0101. Okay, I need, but here I can take out my data parallelly. Okay, so here I can take out my data parallelly. So what I'm going to do, so in the 4th clock cycle, after 4th clock cycle, my data is ready, my data is stored, then I can just read out it parallelly. So I don't need another clock cycle. So in the 4th clock cycle itself I can read out the data. So all total I need 4 clock cycle for processing the data, because I don't need any extra clock cycle for reading the data or using the data. So if for any n bit single serial input parallel output shift register, I need n clock cycle for processing the data. Okay, so let's proceed to the third case, that is the parallel input and serial output shift register. So if I initially, again, suppose I want to store it, I want to store 0110 into my shift register, and then I will take out this data or read out this data serially from its serial port. Okay, so here you can see that suppose initially it is in 000 state, means it is recess state. Then since all the flip-flops inputs are parallelly connected, so what will happen, I just need 1 clock cycle to store the data, whole data. So 000110, this data will be 0110, this data will be stored into my register in the first clock cycle itself. So after first clock cycle I will have 0110 ready in my register. Then I have to just read out this data, right? But I can read out serially, so I need obviously another 4 clock cycle. So I need another 3 clock cycle to read out the data, right? And that I think you can understand why, right? So 0110 will be used, it can be used or read out from the serial port. Okay, so total for storing and using I need 4 clock cycle, just like the previous case. Okay, so that's all. So storing and using I need only 4 clock cycle, okay, for parallel input and serial output data. Now let's proceed to the next case. So that is pretty simple, that is parallel input and parallel output shift register. So what is here we are going to do is that, suppose we want to store this 0110 into my register, right, and then I will take that out parallelly. So obvious, it is parallel input, so only 1 clock cycle is sufficient, because all the flip-flops are working simultaneously and driven by the same clocks, so synchronous operation. So I just need 1 clock cycle to store the data 0110, and in the same clock cycle I can read out the data, because that is parallel output. This is parallel output, right? So just 1 clock cycle is sufficient to read out the data. So here you can see that there is no shifting operation, unlike the other cases, the 1, 2, 3 cases, that is single input serial inputs, serial output, or serial input parallel output, or parallel input serial output. In parallel input parallel output there is no need for shifting operation. So basically it's just like a normal register, and you just need 1 clock cycle to store the data and read out the data. Okay, it works like a simple register. Okay, so parallel, but we consider this is it's considered as a subtype of shift register because for generalization only. Okay, so let's summarize our discussion is that, so suppose for n bit shift register, so we can have 4 types of register that we already discussed, and we need, so processing means, so we can have different scenario where our application where we need to use different shift register, right? So because in fact the processing means the processing of data. So for processing of data means the storing the data and reading the data through the shift register. Okay, so depending upon the shift register type, this total number of clock cycles for processing will be different for different shift registers, different types of shift register, right? So here we can see that for single input single output register I need n clock cycle for storing and n minus 1 clock cycles for reading. So total for processing I need 2n minus 1 clock cycles, right? So simply you can understand that this SISO means single serial input and serial output shift register can be used as a delay element in your data processing pipeline. It's just like a buffer. Okay, and it will insert some delay into your processing. Okay, so in this whenever you need some delay element in your data processing pipeline, you can use this shift register, this type of shift register. Okay, that is single input single output shift register. Now another thing is that for single input, the serial input and parallel output shift register I need n clock cycle for storing and I don't need any extra clock cycle for reading, right? So total I need n clock cycle for processing. Okay, similarly for parallel input serial output shift register I need total number of clock cycle for processing, again n. So for n bit shift register I need n clock cycle for processing. So let me give you one example of where you need this type of shift register. Okay, so let's just consider this scenario. Suppose you want to you have a computer and you want to write an email and you want to send this email by your broadband system or your telecommunication network and transfer to your friend. Okay, he is also using a same telecommunication network. Okay, so suppose person 1, suppose you are writing an email, so your computer is processing your data, but your computer can process your data parallelly for faster operation, right? And but whenever you are going to transfer this data, so your email data, after processing you are going to transfer the data, suppose your communication link cannot support a parallel data, then what you have to do? For this we are basically use modem, where we use a parallel to serial conversion. So modem contains basically this parallel input and serial output shift register. Okay, so you might be aware of this telecommunication modem, this term. So this modem is basically used process the data such a way that it can convert the parallel data into serial data, and then that is transferred to the communication link, and then again on the other end where you are going to send that your email, you have another modem in your, with suppose your friend is using, then that modem will do the reverse operation parallel to this serial to parallel operation. Okay, so that will do the serial to parallel operation. Okay, so your your friend's computer again process the data parallelly. Okay, so your that modem will convert that serial data to parallel data, and that parallel data will be processed by by the computer. So basically your device, our devices can actually process the data parallelly, but sometimes our links, our communication link or channel does not allow parallel processing of data. So that's why we need to send the data serially. Okay, so in this type of scenario we need to use this type of register, and that is parallel to serial conversion or serial to parallel conversion. And basically this is one typical example where telecommunication modem are used, where we have this type of registers, the parallel to serial and serial to parallel conversion can be possible. Okay, this is just one example. So there are many other examples can be possible, so you can just search it out and you can. So this is a basic thing that I would like to I have discussed regarding the shift register. And finally the parallel input and parallel output register is simply a normal, works like a normal register. It is not there is no shift operation at all, because in one clock cycle you are storing the data, and in the same clock cycle you are also reading out the data. Okay, so for processing you just need one clock cycle. So that's all. So so this is a basic concept behind shift registers. We discussed different types of shift register. Okay, so that's all, and with this I'm going to end this lecture. And if you have any doubt, please drop a comment in the comment box, and that's all. Bye. Okay.